This is the graph of y equals tangent x, and we're going to use it to look for an inverse for the tangent function. Like the sine and the cosine before it, the tangent function is not one-to-one, so it doesn't have an inverse as it is. Unlike the sine and the cosine before it, there's maybe kind of a more intuitive way of getting a piece that is one-to-one that we can talk about an inverse, and that's by looking at one complete period of the tangent function. If I just pick two of the asymptotes and look in between them, I get one period of the tangent function that is one-to-one, and we can talk about an inverse of the tangent function just on that one period. The obvious one to take is the one that matches the sine function from negative pi over 2 to plus pi over 2 between those asymptotes. So my function, the tangent function, y equals tangent x, we're going to look at that function just on the domain from minus pi over 2 to plus pi over 2. And since there are asymptotes, the tangent function isn't actually defined at either of those points. I'm going to leave the endpoints out by using parentheses there. The range of the tangent function, all real numbers, goes up as far as you like, down as far as you like. So you can say negative infinity to infinity. You can say all real numbers like that. And now we can look at what happens with its inverse. Like the sine and the cosine, we can call this arctangent if we want exactly the same thing, two names for the same thing. I don't know why. Probably two different people made the notation independently of each other and they both stuck. And you do see it both ways. The domain of the original function is the range of the inverse. So the range of my inverse tangent function is minus pi over 2 to plus pi over 2. And the domain is the range of the original function, so that's all real numbers. So we're not going to run into domain problems like we sometimes do with the inverse sine and the inverse cosine. Its domain is all real numbers. Let's put this to work. If I want to evaluate the inverse tangent of, let's say, root 3, I'm looking for the angle that's in the right range between minus pi over 2 and plus pi over 2, whose tangent value is the square root of 3. And we can use the unit circle for that. The angle whose tangent value is the square root of 3 is pi over 3 in quadrant 1. And we're done. So the tangent of pi over 3 is root 3. The inverse tangent of root 3 is pi over 3. What if I have the inverse tangent of, let's do negative root 3 over 3. So I'm looking for the angle that's between minus pi over 2 and plus pi over 2, quadrant 4, whose tangent value is minus root 3 over 3. Your first instinct might be 11 pi over 6, which does have a tangent value of minus root 3 over 3, but 11 pi over 6, even though it's in the correct quadrant, is not in the correct range. So we're going to have to name a coterminal angle with 11 pi over 6 that is in the right range, and that will be, we'll have to call it negative pi over 6, coterminal with 11 pi over 6. So there's the inverse of the tangent function.